Greetings. Let's prove that if we have an abelian group G and we have a homomorphism from G to itself, then let's prove that F is actually a homomorphism from G to G if the homomorphism is defined as x cubed. So for any element, it will be taken to the third power, put in operation with itself 3 times. And how we will do this is, we know that G is abelian, and a homomorphism is defined as this. So for any AB that belong to G, it must apply for this homomorphism to be valid, that f of A, well, f of A in operation with B equals f of A as a whole in operation with f of B as a whole. And that means that we now have to take into account the concrete function that the homomorphism f represents, which is x cubed in this case. So we can see, so for any AB in G, any 2 elements in G, f of AB will be following this, and that means AB to the third power. And how that is written with operation regarding groups by default is AB carefully like this, with this same order. We just write it 3 times in a row as an operation, 3 times in a row like this, because that accounts also for cases when the group would not be abelian. But because we know it is abelian, we can reorganize the terms as we want. So it's the same as A, B, because G is abelian. And now these 2 parts can be rewritten as A cubed, B cubed. And now we can refer back to the definition of the homomorphism. So is F from G to G a homomorphism? Well, we can finally conclude, because A cubed and B cubed are f of A and f of B. So f of A times f of B. So what has been concluded here is that yes, f is a homomorphism from G to G when f equals x cubed, because the identity f of AB equals f of A times f of B, where the operation between AB inside here is the same as the operation between f of A and f of B as a whole. And by the way, f of A will again belong to G, f of B will by itself belong to G, and the operation between the whole f of A and f of B is the same as between A and B themselves inside the F. It's because we are even doing the automorphism here. So this is a homomorphism, and concretely said, it's a subtype of a homomorphism. It's called automorphism because it's from a group to itself. It's from the same group to the same group. And so for that reason, in this homomorphism equation, the functions or the operations that take place both belong to G. There's no other group they would belong to. So between A and B, and the homomorphism of A and homomorphism of B, the same operation is applied.